How you doing, guys? Welcome to another video. This is still topic 1, volume 4, where we're looking at geometry. We've put together some of the early parts of So here's an example of using stoichiometry and the solutions. A solution of 20 centimeters cubed of 0.25 mole per decimeter cubed of lead nitrate is added to a large volume of potassium iodide solution to produce a brilliant yellow precipitate of lead 2 iodide. Write an equation for the reaction and so determine the mass of precipitate formed. So the first thing we need to do here is write a balanced chemical equation. So this goes right back to topic 1.1, where we need to be able to write equations when we're given the reactants and products. So lead nitrate, Pb bracket NO3 2 aqueous plus potassium iodide, Ki, forms PbI2, which is a solid lead iodide, plus, well, what's left over? Well, our potassium and our nitrate are left over, so they must be in the equation as well. Is this equation balanced? No, I've got 2 potassiums on the left and I need 2 potassiums on the right, or the nitrates. That will balance our reaction. Now, in terms of the stoichiometry, I've been given some information about lead nitrate. So I'm going to write those under lead nitrate in the equation. I've also been given some information about potassium iodide, so I'm going to put that there as well. Now, they told me that I had a large excess of this, so this is like the excess reagent. What was the thing they wanted me to find? They wanted me to find the mass of lead iodide, so I'm going to call that X. So just in terms of how this equation works, well, they told me that the Ki, I had a large amount of it, so my PbNO3 must be my limiting. So that's what I'm going to start to work with. I always start working with my limiting reagent. So I need to find the number of moles of the lead nitrate. I've been given the concentration and I've been given the volume, so I use N equals C times V to determine the moles. Remember to change the volume to decimeters cubed. So I've worked out the number of moles to be 5.00 times 10 to the negative 3 mole. And now I'm in a position to use the balanced chemical equation to work out the number of moles of my unknown. So the thing that I want is PbI2. What's the stoichiometric coefficient? It's 1. The thing that I've got is PbNO3. So it's a 1/1 relationship. So the number of moles of PbI2 is the same as the number of moles of lead nitrate. So 5.0 times 10 to the negative 3, or written as a decimal as such. In the question, I've been asked to determine the mass. So the mass of PbI2, using the formula, mole times molar mass, will be equal to the number of moles, which we calculated above, times the molar mass of PbI2, which is going to be big because it's got iodine in it, and lead, which is heavy as well, 461.00, gives me my mass of 2.31 grams. So I would form 2.31 grams of precipitate from that reaction. Here's an example where both the reactants and products are all solutions. So sulfuric acid is a strong acid that reacts completely with the alkali sodium hydroxide to produce water and a salt sodium sulfate. Again, we've been given all the reactants and products so that we are expected to write an equation. Calculate the volume of 0.376 mole per decimeter cubed sodium hydroxide required to completely neutralize a certain amount of sulfuric acid. So there's a lot of things going on here. We've got a lot of bits and pieces, but we need to make it a little bit clearer so that we get a better understanding of what the question asks. So the easiest way to do that is to write the equation and then put the things underneath. The word neutralize means that it will react with. So we've got the sodium hydroxide reacting with the sulfuric acid. So sulfuric acid, H2SO4 aqueous, plus sodium hydroxide, NaOH aqueous, will form a sodium sulfate salt, Na2SO4 aqueous, plus H2O. So, is this balanced? Well, let's have a look at the sodiums. No, I've got 2 sodiums on the right and only 1 on the left, so I need to put a 2 in front of the NaOH, and then that forces me to put a 2 in front of the water. Now, let's start with the sulfuric acid, H2SO4. What information were we given? Well, we were told that we need 25.5 centimeters cubed of a 0.506 molar solution to neutralize some sodium hydroxide. We were told the concentration of the sodium hydroxide, and our volume was our unknown. That was the thing that we needed to find. So again, we start off working with the one that we've got the information for. So I've got information for sulfuric acid, H2SO4. So the first thing I'm going to do is use the equation, number of moles equals concentration times volume, to determine the number of moles of sulfuric acid. I need to know the number of moles before I can use the equation. So plugging those values in, remembering to change from centimeters cubed to decimeters cubed, gives me 0.0129 mole of H2SO4. Now I can use the ratio in the balanced chemical equation to work out the number of moles of NaOH. The thing that we want, NaOH, 2. The thing that we've got, sulfuric acid, 1. So it's a 2 over 1 times the number of moles of the thing that we know, which is H2SO4. So we can work out the number of moles of sodium hydroxide by multiplying the number of moles of H2SO4 by 2. Now, to find the volume, volume's always the one that's a bit tricky because you never have to find it all that often. You find a lot of concentrations and a lot of number of moles. So the way I do this is I start off with writing the equation that I can remember. N equals C times V. And then I can rearrange that to find the volume. So volume of NaOH is equal to the number of moles, N, over the concentration, C. We found the number of moles in the last part, 0.0258. The concentration, well, that was given in the question, so we needed to use that somewhere. That's going to give us the volume of NaOH that we need in decimeters cubed. So 0.0686 decimeters cubed. Now, what does that mean? Well, if we transfer that to centimeters cubed, that would be 68.6 centimeters cubed, which is the same as 68.6 mils. So a fairly large amount of that solution. So solutions can also contain limiting reagents. So remember that if you've got a limiting reagent question, or you think it's a limiting reagent question, you'll be given the concentration and the volume for both of the reactants. That's how you can tell that it's a limiting reagent question. So here we have a solution of sodium chloride and a solution of silver nitrate, and they've given us the concentration and the volume for both. We're told that it generates a precipitate of silver chloride. Determine which reactant is in excess and calculate the mass of precipitate formed. So again, we're not given an equation, but we're given the names of the reactants and products, so we're expected to be able to write an equation. Sodium chloride, NaCl, aqueous, plus silver nitrate, AgNO3, aqueous, will form a precipitate of silver chloride, AgCl, and then the leftover would be the NaNO3, which will be aqueous. Again, a good tip is to start with the equation and then underneath write what you've been given about the reactants. So the NaCl, we have 20 centimeters cubed, and we have a concentration of 0.499. So I'm going to go through and put those underneath the balanced chemical equation. It just makes it a little bit easier. The silver nitrate, well, we've been given 25.4 centimeters cubed and a concentration of 0.275 molar. Okay, a limiting reagent question, the first step is always the same. We need to calculate the number of moles of both of the reactants. So we've been given a concentration and a volume, so we can use N equals C times V. So I do that for both, remembering to change to decimeters cubed, dividing by 1,000. So many students will miss that step. So I can work out the number of moles of NaCl. I can then work out the number of moles of AgNO3, doing the same process. Number of moles equals C times V, changing V to decimeters cubed. Once I've got the number of moles of both, in this reaction, they were a 1-to-1 ratio. So what we're looking for here is the one with the smallest amount of mole will be the limiting reagent. But remember, that's not always the case. It's just the case in this reaction. So in this case, the limiting reagent will be AgNO3 because it has a smaller number of moles than NaCl. And we need to look at the equation to do that. If you need to do some revision, go back to the video earlier on in the topic. Now we've determined the limiting, we can work out the unknown, the number of moles of the precipitate AgCl. What's the ratio between that and the limiting? Well, it's 1-to-1. So the number of moles of AgCl is the same as the number of moles of AgNO3. Now we've got the number of moles of our precipitate, we can now work out the mass. Mass equals number of moles times molar mass. We've got the number of moles from the limiting, and then we multiply by the molar mass to find the mass. And in this case, the mass of the precipitate would be 0.966 grams. And I would round this to 3 significant figures because in the question I was given 3 significant figures. Keep the numbers in the calculator, do your rounding at the end.